What is up, YouTube, and welcome to episode 67 of the Chaos Daily. We're in the office today. Been procrastinating. This episode's super late today. It's super late. But that's... I've got a lot of stuff on the CAD. I've been working my butt off, okay? Yeah, I've been putting the hours in these last couple of days. I've been staying up way later than I normally do, sleeping way less. Just getting a lot of these wing structures done in CAD. And it's not that they're difficult to do. Well, some of them are a bit difficult to do. Gyroids and lattice structures work at a microscopic scale for creating highly strong, lightweight parts, but at the macroscopic, which is what we're doing, I mean, I can try and print them, but there's no way I can model them. This is the issue. Without creating plugins or software that specifically takes a volume of a shape and then automatically creates the internal lattice structure whilst leaving the skin of a certain thickness, like you do with slicers and that when you're slicing for 3D printing, then I can't do this. It's not possible in CAD, not without those tools, those plugins. To do it manually is impossible, and I don't have the computing power for it. So that leaves us with, we wait until there's a slicing software that does gyroids, because for some reason, and I'm talking to you Chitterbox, and I'm talking to you Lychee, why the hell is there no gyroid pattern? Why do you have this basic tessellated Isogrid pattern, but you don't have gyroids? When all of the plastic FDM printing slicing softwares, the majority of them have multiple kinds of gyroids. Or they even have, dynamic gyroids that change their infill density depending on how close it is to the skin or top or bottom layers and stuff like that. Why do we not have this in Lychee or Chitterbox? Why? Is it too hard? Because out of FDM printing and SLA printing, the resin printing is going to get the most gain out of these structures. So why don't we have it? Why haven't you done it? Anyways, rant over, right? You guys, Lychee, Chitterbox, get your act together. Those need to be in there. It's standard. Not behind a paywall. Get them in there as standard. As soon as you do that, your software becomes a lot more usable for the wide engineering community, because at the moment the engineering community can't use these resin printers to do stuff because the tools that are available to them are from model makers, and we don't want to make models, we want to make engineering stuff. Anyways, so let's jump into CAD and I will show you what I've been up to. Okay, so let's start off with the gyroid. I just have one block. I've created this pattern. This is a patternable block. So you will notice that there are these little floating corners. These floating corners correspond to the corresponding pattern that is on the other side. Say, for instance, this curve here would continue here, and then it would continue here. So that corner there constitutes this cutout here, and that's the edge of this corner. So this is a cubic pattern of a gyroid. This is another reason why a lot of the gyroids and patterns that I have found online in GrabCAD or stuff that you import from Blender or whatever, even if they are a closed mesh surface, the problem is when you pattern them, these corners or these edges are not perpendicular to, these edges are not parallel to the cubic face, and you can't pattern them, and it introduces errors. The other issue that I have found is you'll notice that mine is full of holes. It looks like cheese. These holes are also intersecting points of the surface that when you tessellate the geometry, when you convert it from a surface to a quad or a tri-geometry, there are errors induced through the math in these areas, and when you go to do Boolean operations, the stuff that's going on in these points don't Boolean. The math, it's like divide by zero stuff, trying to put a hole through a Mobius strip surface. The math just doesn't want to deal with it, so those are the errors that we've been seeing. So I pretty much stopped working on this. Jotham is still playing with the one that I sent him. We'll see how it goes. I've not got high hopes, but yeah, if we can print one gyroid just to show that we've done it, then sure. But so far, the numbers I've looked at for like the weight of this block patterned out minus the cutting out of the wing, the volume, it's heavier than the 2mm wing the 2mm skin thickness shell that we've already printed. So next up, this is another kind of gyroid, a triply periodic surface or something. I can never remember what the full name is. Anyways, this is a much simpler pattern. You can see one of the blocks here. It's basically it's 3 tubes that intersect that are shelled with a fillet. Really simple. This you can model up. This is easy to pattern. You can see for the most part the Boolean works. For some reason in these sections here, and I believe it has something to do with the pattern intersects this line here where this block and this block meet. Even though this is a solid object, when it goes to do the intersect for the wing skin surface here through this area, something about it doesn't like, and it won't do it. So when I repeated the pattern for this gyroid, I repeated it in columns. So that's why these two columns here and this column here haven't been Booleaned, because of some weird reason it didn't want to. So this one is out the window as well. But I wanted to point something out. If we look at the properties for this, and this isn't even counting the skin, right? This is only going to give us the properties for what's visible, which is this structure. And we look at the weight of it. That's 116 grams for what? A pretty pattern? Like this is way heavier. This is heavier than just the wing skin at 2 mil thickness. So this is not a viable option. So for the most part, I can safely say gyroids are out of the picture. We will print some just because they look cool and to show how they print and like all that stuff, but they're not viable. They're too heavy and they're too difficult to work with. They're too finicky, they're too resource intensive, like for the computer and stuff like that. Not worth the effort. And especially for the weight that you get out of them, it's just not worth it. If these were microstructures like sponge, like tiny little holes and stuff, and these wall thicknesses were at the very resolution limit of the printer, and you scaled the thickness of the walls for the gyroid to the size of the pattern, and for the volume and the density of the pattern, to the point where it was optimal, you would end up with a resin sponge that would not necessarily add any structural value or strength to the part. So yeah, we're gonna just go no. The gyroid's out of the picture. So next up, I've designed this, and this is you'll probably recognize. This is an Isogrid. It is basically I created a 2mm shell of the wing. I duplicated the solid block, the original blank. I duplicated one of them. I shelled to 0.55 millimeters, and the other I shelled to shell 1, there's 0.5, shell 2 millimeters. So yeah, so this is a 2 millimeter shell that I then created a triangular pattern, a grid, and just extruded them through the 2 millimeter shell. And that left me with an Isogrid. Now, this 2 millimeter shell intersects with the 1 millimeter shell by that 0.55, so it sticks up here from the intersection plane by 1.45 millimeters. So we have a 1.45 millimeter Isogrid pattern on the inside surface of this wing. So we're going to print one of these and test this. This is the other one I wanted to do. Now I've added these just as stiffeners, these longitudinal stiffeners, but they're not necessary. We can print it like this. Now, the 0.5 millimeter skin in between the ribs could be quite flexible and loose, but going by the stiffness of the 0.5 millimeter shell that we've already printed, I think the gap between there and then the box shape that is generated between this ribbed contour that's on the inside, plus it should create stacked cylinders that add a bit of strength. So I will print one that's just like this, and then we will print another one with these longitudinal spar structure things in them. I'll probably go in and add some holes to these just to lighten them up some more. But if we look at this and we go properties, physical, update, we look at this. This is 34 grams. If I remember correctly, the 2 millimeter skin shell, which was 77 grams. Let's bring the skin in and have a look, because some of this might be intersecting mass. Okay, so yeah, that's really weird. That's telling me we're going to get 30 grams of weight for this structure. So I think these numbers that I'm getting, my specific density might be off compared to what the actual specific density on the Siraya Fast Grey is. I will have to update this number so that the numbers reflect. So this might not be real world, but it does show that if that's going to be 30 grams compared to the 24 grams of the 26 grams of the 5 millimeter shell, if we're looking at, say, let's be generous, all of this internal structure is an extra 15 grams. We're still lighter than the 1 millimeter shell, but we've added an additional boatload of structure and strength to this thing. So this is a promising system to use, as well as the Isogrids. So back on the topic of gyroids and lattices and nested structures, this is another potential one that we could use. This is a lattice that I've put together. The bonus of this is that I can double the strength of this for less than double the weight. This lattice structure is nestable. What does that mean? Well, it means, now this one's screwed up a little bit, all the fillets have buggered off, but you can see that it's the same pattern that is intersecting with the original one, but they're two separate solids. That's one solid, that's another solid. Nowhere do they touch, which means that when this is laid out on the inside of a wing, the force is distributed through two lattice structures inhabiting the same volume, the same space, and because the two lattice structures don't touch or interact, the force transfer through them is independent. So you get twice the amount of force transfer through the same volume or space that what you do for a single lattice structure, and you are almost doubling the weight. But so for the most part, this is a really good system. You can get a great deal of strength out of this for the area and density of the lattice. But again, this is going to be quite heavy because of the way that it has to distribute to the entire volume of the inside of the thing. And say that this lattice structure constitutes a 60 to 70% remaining volume of the original volume of the wing blank. That's still leaving, 40-30% of the mass that you still want to get rid of. You want to try and bring that down to about 95% mass reduction, not 30 or 60. So these lattice structures work, but in order to get them down to that 95% density, the 95% density reduction, then you need to scale the lattice structure up. And by that point, again, the points at which the lattice touch the skin of the wing are further apart. So you're getting less force transfer than you really need, and you end up with a weak part anyways for no gain. So I think it's the final nail in the coffin for gyroids and lattice structures. Yes, they're neat and all that, but computationally, the amount of effort you have to do to make these structures, to get them to work, to boolean them, they just look cool. They're not actually practical in many cases for what we're doing. In order to get the strength we need, we have to focus on doing things like smart and targeted structural generation. We have to look at what is the forces of the wing that we're going to be using and put structure there and only there where we need it. So I had to play with using FEA, finite element analysis, or stress simulations, that sort of thing. Now, Inventor has a shape generating tool in it. So I can come in and say, okay, simulate the force properties. Now I just constrained this one face on the end here and applied a force over the entire top and bottom wing surface so that it's all distributed and equal. It's not the perfect way to do it, but it's pretty damn close. I couldn't get it to work, basically. It's not designed to make this kind of shape generation analysis. It's designed for tressellating plates or struts or frame assemblies and stuff like that. It's designed to take stuff that is blocky and frame that has forces traveling through it in certain ways. This kind of application is not what the tool is intended for, so it doesn't give me the results that are meaningful for this kind of application. So the tool that's built into Inventor isn't designed to do this, so I couldn't use shape generation to do this kind of thing. And there's one last thing I want to go over. So I made molds. If we're going to be talking about wing strength and structure with resin, somebody's going to ask, why don't you just print molds and do it like RC Rami? In fact, somebody has. A couple of people have already. Now, sure, this is true. We can just print molds and we can make them with fiberglass. I have some fiberglass here. I don't have any carbon fiber. I'll have to order some to test it with carbon fiber, and I think I'll have to order the correct kind of resin, because I do not think that UV curing resin will cure in a closed mold with no UV light. So I think I'm going to have to get 2-part epoxy resin so I can do this properly. But I do have fiberglass fabric and stuff that I can do this with. So I'm going to print a set of molds. I'm going to get some resin, and we're going to make some wing blanks using the fiberglass that I have. And then we can look at, okay, what kind of internal rib structure and stuff or carbon fiber spars do we place on the internal, or do we use a foam blank, or like all of these different questions. That option is available to us, but it kind of ignores the problem we are trying to solve, the question that we are trying to ask. What is the optimal solution for internal wing structure for a resin printed wing? How do we go about designing that structure. What is it going to look like? How is it going to interact with the skin thickness? What kind of skin thickness do we use? How do we print it? Do we print it on the trailing edge like I have been doing, which I've been getting much better success at than printing the wings vertically on the roots or the tips, or do we print them on the leading edge? Like, or do we print them flat with a hell of a lot of support material and use a lot of resin? There are a lot of different questions that are still left to be asked. So what this is about is going through the process of testing all these different elements, testing all these different parameters and aspects of this problem, and finding the solutions and doing it in the correct engineering and scientific manner, so that you guys can see and understand what it is I've gone through in my head already. And so yeah, that's the reason why. And printing molds to use fiberglass as a reinforcing agent, as a reinforcing aggregate, kind of sidesteps the problem we're trying to find an answer to, and sort of goes, well, just do it a different way. And well, in that case, then sure, I should just go down to the CNC shop and get them to mill out a bunch of molds for me, and I'll just do a bunch of carbon fiber molding, because that is the best way to make wing structures. We know this. Like that's like, until somebody comes up with a better material than carbon fiber, we know that the best way to make wings is carbon fiber with internal ribbed lattice structure, with honeycombs or whatever. We've like, over the decades of research and development that has gone into the aerospace industry and aviation in general, we've pretty much solved this problem. We've nailed it down. We are asking a specific question: what is the best way to do it for resin printing? 3D print resin planes. And that's what we're trying to ask here. The questions have already been asked for FDM printers, and a lot of answers have been found, but there are none for resin printing. So yeah, a lot of me talking today. Sorry, we're back in the office. Yeah, hopefully that gets you up to speed with what I've been doing. Like I said, I've been working my butt off. This episode's late because I've been kind of putting it off, because I've been thinking about how do I get all of this information across to you. I'm sorry, this was a total information overload, but there was no other way to do it, and that's kind of why I was putting off doing this video, was because of the amount of information I had to get across to you guys. So if you're still here watching me and you haven't skipped or anything, thank you so much. I really appreciate it. If you have skipped ahead or you completely stopped watching, I don't blame you. I really don't. My head hurts too. So yeah, make sure you hit the like button. Make sure you subscribe to my channel and to the other channel. If you've not, go watch the video twice if you haven't already. And as always, I've been Chaos. Until next time, expect the unexpected, and I will see you guys later. And a special thank you to all my patrons that help support the channel. If you would also like to support the channel, there's a link in the description.